Algebra 2, Concept 16A, Teacher Talk, Factoring and Finding the Zeros of Polynomials. So, number one, what does it mean for a polynomial to be factored completely? Well, if we go back to the notes, from the notes, it means that you'll end up with a product of simpler or unfactorable polynomials. So they can't be broken down any further into things multiplied together. So when you completely factor a polynomial, you will have a product of simpler or unfactorable polynomials. What are the steps, or what are the process you can go through to factor a polynomial? And this is so good to have in your mind, just to always have this process as soon as you start factoring. The first thing is it's good to have your polynomial in standard form. Then, number one, look for a greatest common factor. It has to be amongst all of your terms, and it can be a number, a variable, or both. Number two, then you're going to look at how many terms are in that polynomial, because that will give you a clue of which factoring direction to go. If you have two terms, then you will often have a special factoring pattern, a difference of squares. So if you have two terms, be on the lookout for a difference of squares. And you can factor as that the sum of the first thing times the sum of the second thing. So a way to write that in general form is a squared minus b squared. That's a difference of squares. We'll factor as a plus b times a minus b. And order doesn't matter in that case. Now, if you have three terms, be on the lookout for quadratic factoring. And so this is the method where you think of it in terms of standard form, a, b, and c. Two numbers, I've got things on top of each other. So I'll rewrite this down here. Two numbers that multiply to give you a times c, and then will combine to give you that b value. And then your two numbers go here. And then you can move forward. And that's our quadratic factoring by grouping. And then finally, if you have a polynomial with four terms, just jump right to grouping. So split that polynomial, two terms and two terms, look for greatest common factors, and then move forward with that grouping process. So let's try it. We're going to factor these completely, finding the zeros of the functions. So we'll set our factors equal to 0 and solve. Before we factor, however, we're going to predict how many roots, and we're going to do that by looking at the degree. So what degree is 3a? You're right, it's third degree. So that means there will be 3 roots for this. Now remember that factoring process. The first thing you want to do is you're going to look for a common factor, and we have a common factor of x, so we'll factor that out. Now we look within our parentheses. Notice we have 3 terms. So remember what we'll do? That's right. We'll look for quadratic factoring. Two numbers that will multiply to give us negative 12 and combine to give us negative 1. So that's negative 4 and 3. So it will factor as x minus 4 times x plus 3. Now what we'll do to find the zeros is we'll set each of those factors, including the x, equal to 0 and solve. So our 3 roots are 0, positive 4, and negative 3. All right, now b, our degree is 7, so we will have 7 roots. First thing we're going to do is factor out a greatest common factor. So we can factor out 9p to the 5th, and we'll be left with p squared minus 4. We'll keep factoring. See how we have 2 terms, and we ask ourselves, is this a difference of squares? It is, and that can factor as p plus 2 times p minus 2. Now let's set each of those factors equal to 0, and we'll solve. So we'll start by dividing by 9, and then taking the 5th root of p to the 5th. So p will equal 0. P will also equal negative 2, and p will equal positive 2. Now you may be thinking that's only 3. I thought we were supposed to get 7 roots. Well, if you have a root that is to a power greater than 1, so for example 9p to the 5th, this answer accounts for 5 of your roots. So technically, p to the 0 counts as 5 of our roots, and then 1 and 1, because both of those expressions were to the first power. Funny, I know. All right, now C. Notice we have 4 terms. So let's start by factoring by grouping. I'm just going to put a little dividing line after my second term. I'll look at my first 2 terms and factor out a common factor of x squared. I'm left with x plus 3. I'll factor out a negative 4 and left with, not x, y plus 3. Now my common factor is the expression y plus 3, and I'm left with y squared minus 4. I can keep factoring my second expression. It's a difference of squares. And I just keep doing that until I'm all done. Now let's set each of those equal to 0 and find out what our 3 roots are. So we'll have negative 3, negative 2, and positive 2. All right, for D, it's a power of 2, so we're going to end up with 2 roots. Notice it's 2 terms, and so you ask yourself, is it a difference of squares? It sure is. You can square 4 to get 16. So it will factor as y plus 4 times y minus 4. You're going to set those each equal to 0 and solve. So our 2 roots in this case are 4 and negative 4. Oh. All right, that concludes our teacher talk on 16A.